So hello guys, welcome back to AutoCAD tutorials. In today's session, we are going to see how we can calculate the BBS of any kind of mesh reinforcement. But where do we find mesh reinforcement? We find mesh reinforcement in our raft and flat slabs. So here I have a model of a flat slab where the reinforcements are arranged at the spacing of 200 center in both directions, and the dia of reinforcement is of 10 mm. So how we can find our mesh reinforcements BBS using AutoCAD? It is very simple and it will take hardly your 1 to 2 hours, and you can get the complete mesh reinforcement of this plan. So what you have to do is, first basically you have to create the outline where your reinforcement are placed. So I have placed my outline using certain lines and polylines which I have kept ready over here. As you can see, I have made two layouts. Why two layouts is required is one for X direction and other one is for Y direction. Now what I will do is, in this layout, I will place my reinforcement using a line. So for that, I will take my line command and I will place my reinforcement from start to end. The benefit of placing the reinforcement from start to end is that we can trim off the excess lines easily. So for that, first I will activate my layer, that is bottom X direction. For that, I will go in layers and I will just switch my layer on here, which is X direction, bottom layout. Okay, I am not finding it over here because I have made it in some other drawing. So I will open that drawing. Here I have arranged my reinforcements, as you can see, which is given as per drawing arrangement. So to arrive at this stage, what we can do here is, we have to first create a line. For example, I am creating a line from start to end. Now what we will do is, we will create an array at the given spacing of the drawing. So I will take array command and I will select rectangular array from here. Then here I want only one set of columns and multiple set of rows, but at a distance of 200 mm spacing. So now as you can see that our reinforcement has not been arranged yet, but it is going in some other direction. So what we have to do is, first we have to check that this associative option is not activated. Now here on this flyer, until it becomes orange, we have to keep it here and then click and drag in the direction where we have to place our reinforcement. And we will just click at the point where our reinforcement will end. Now what we have to do is, we have to trim off the regions where reinforcement is not present. So for that, we will use trim command and I will just select the patches where reinforcement is not there and we will trim off the additional lines. So in this way, we have to keep trimming our surface and additional lines to get the reinforcement clearly visible where we have reinforcements. So by continuing the same procedure, we will arrive somewhere at this stage. Here I have kept my X direction reinforcement and Y direction reinforcement ready. So now what we have to do is, we have to use the AutoCAD command data extraction, that is DATA, data extraction. Now here AutoCAD is asking me to create a new data extraction. I will go with next. Then he will ask me to save this current drawing file. So I will save by any name, X and Y direction layout. Okay, one, save. Now we will do next. Now we have interest only in lines, we don't need polylines. So I will uncheck this option and we will select next. Now in line, we have various set of options, which data we need to extract. So yes, first of all, we will uncheck all of the options. Now we will select length because we are interested in length. But also we have to see that we have two reinforcements in this drawing. One is X direction and one is Y direction. So we will keep this layer option on as well because we have made our reinforcement in two layers. X direction for X layer, X direction reinforcement, and Y direction for Y direction reinforcement. So here we will press next. Now you can see here we have got the column of count, name, that is line, and layer, in which layer it has been made. You can see here we have X direction reinforcement. I will do a full preview here. X direction, Y direction reinforcement, and X direction as well. And some beam layer is also there, which original drawing has in it. So now what we will do is we are going to save this in Excel format. So we'll click on next, and then here we have output data to external file. So I will select this, and here some path has been generated. So we will click here and save it the place where we want to establish this. So I will just go and save this here as bottom X and Y direction BBS. So I will save this, then I will press next, then finish. So after doing this, we have our complete data of mesh reinforcement ready. Now what we have to do with that data, let us see. So first we will go in, in the place where we have saved it. So I will just open up that Excel file. So here we can see that we have got all the details with length of the line. So you can see apostrophe mark over here. We don't want that. So what we will do, we will select this column D, then we will go on data, then we will select text columns, then next, and now finish. What this will do, this will convert everything into the numbers. So now, first of all, we will apply a filter over here. Why filter? Because we have to segregate our X and Y direction reinforcements. So first we will select Y direction reinforcement or X direction, it's up to you. And we are going to select this complete set of data. Control C. We will create a new sheet and we will paste it over here, and we will rename this as Y direction. I will show you how to do this, and you can repeat this for the same. So I have copied X direction, so I will make it as X direction reinforcement. So now next what we will do, we know that dia is there. Then what we have is our development length, if any lap is involved, and then our total length. So now we have dia of 10 mm, and you can see each and every length here is in mm, so we will try to keep everything in mm. So I have just dragged our 10 mm dia. Now suppose our lapping is of 40D, so I will press 40 into D. Now the total length is, we have to provide provision for lap as well, since the direction is length is more than 12 meters, so we will get here lap as well. So what we will do, length plus, now we have to make provision for laps, so I will do round down this digit, this cell, divide by 12,000, we have to keep everything in mm, comma 0 into our lap. So you can see one lap has been automatically added. So I will just drag down this over here. Okay. So now what we want is our weight. So for that, what I will do, length into D square by 162 divided by 162 into total number of bars. So in this way, we will get our weight of reinforcement. Now I will again drag it down and I will just do an order sum and press enter. So here I have got some data which is in kg. So now if I want to convert it into metric tons, so I will just divide this data by 1000. So here we got 7,971 metric ton of steel is required in X direction. Similarly, you can do this with Y direction reinforcement, or if you have any certain specific format of BBS, you can just copy this length and this numbers over there and you can directly work with it. So the major data which was of the length required for the bars has been given by AutoCAD. So in this way, we can calculate the reinforcement of any mesh within few hours. So hope you like this video. If you like this video, so do please like, share and subscribe. Thank you.